Good afternoon friends, you are most welcome to ThinkEyes channel. Today we are going to discuss Practicing Anthropology MAAN 003, which is written by IGNOU, Indira Gandhi National Open University School of Social Sciences. Our topic is Anthropometric and Physiological Dimensions and Practicing Anthropology. In Unit 1 we will discuss Design Anthropometry. In Unit 2 we will discuss Physiological Anthropometry. In Unit 3 we will discuss Keen Anthropometry. Let us begin the topic. Introduction part. In this block we will learn about three areas of anthropology, more precisely physical anthropology, where we find that these areas effectively fall under the category of applied science. These areas can be of immense assistance to students' careers after being trained in them. In Unit 1 we will learn about design anthropometry. The use of anthropometry started many years ago, and it was concerned with the collection of data of body parts to design clothes, tools and apparatus, etc. But in the study of humans, anthropology is associated with ergonomics, where the system of man and technique can be combined to reach new goals. Design anthropometry is basically anthropometry utilized to design equipments, gears, etc. with the knowledge of body proportions, and is conducted with the help of measurements of humans to provide them the best arrangements. Design anthropometry plays an important role in bringing the point that different bodily characteristics influence the manner in which people carry out their jobs and reveals human-machine connectivity. 3D scanners have interesting uses on design anthropometry, from body parts measurement to ascertaining clothing size to other body gears. There are other techniques too, like CAD computer aided design, CNC computer numeric control, and PCA principal component analysis. Nowadays anthropologists are professionally accepted in clothing industries, aerospace industries, consultant firms, etc. A strong mathematics and science education elevates the chance of success in a profession associated with design anthropometry. If the anthropologist has the ability to exhibit knowledge of research documentation, proposal and report writing, computing and graphic design, it adds to the benefit in working in the field of design anthropometry. Anthropologists bring an important understanding on the interaction of physical and social environmental conditions and can be strong participants in such an inherently interdisciplinary approach. The health promotion capacity of an environment is understood not simply in terms of the health effects of separate environmental features, example air quality, seismic safety and social climate, but more broadly as the cumulative impact of multiple environmental conditions or occupants' physical, emotional and social well-being over a specific time interval. Unit 2 studies the human cardiovascular functions and health status. The cardiovascular system consists of an interconnected continuous vascular circuit containing a pump, that is heart, a high pressure distribution system, that is arteries, exchange vessels, that is capillaries, and a low pressure collection and return system, that are veins. Effective prevention strategies for hypertension have been briefly described. These strategies include lifestyle changes, regular physical activity, modest weight loss, stress management, smoking cessation, reduced sodium and alcohol consumption, and adequate potassium, calcium, and magnesium intake, etc. Cardiovascular fitness is designated as the most significant component of health related fitness and remains a significant predictor of hypertension. Epidemiological and clinical signals has led to a heightened concern about the potential harmful effects of ambient air pollution on pulmonary and cardiovascular system, depending on the physical and chemical properties of contaminants, time and frequency of exposure. Overall, the unit reviews the interaction of human cardiorespiratory function with respect to their health and morbidity. The last unit, that is unit 3, is on kin anthropometry. Interaction of human form and function creates an acute awareness and application of human variation. Kin anthropometry is a scientific specialization which deals with measurements of persons from a variety of morphological, physiological perspectives and its application to movement. The factors which influences the movement are component of body build, body composition, body measurement, shape, maturation, proportion, measurabilities and cardiorespiratory function. In 1984, Olympic Scientific Congress first recognized kin anthropometry as a scientific discipline. The term was first used by Bill Ross in 1972 in Belgian Journal as kin anthropology. It spread during middle and late 1990s. Kin anthropometry closely associates the physical education, exercise physiology, sports science and medicine, human biology, science of growth, physical anthropology, gerontology, ergometry, and other several medical disciplines. Kin anthropometric data are used to produce various indexes and describe physique. A large fraction of kin anthropometric work deal with physical performance. Kin anthropometric studies are very helpful very helpful in sports, designing of clothes and shoes, designing of furniture, etc. Unit 1, Design Anthropometry. Contents: first we will discuss introduction, then we will discuss anthropometry and design anthropometry, then we will discuss methods and measurements. After all, we will discuss uses of design anthropometry and practice of design anthropometry by anthropologists. At the last, we will discuss summary. Learning objectives are: after going through this unit, you will be able to know what anthropometry and design anthropometry is, know about the importance of design anthropometry in anthropology, know about its methods and distinct measurements techniques, know about its various applications, and know how anthropologists can use their knowledge in the field of design anthropometry. Introduction. The purpose to have a unit on design anthropometry is to take you learners through a detailed exploration of what it is, how it originated, and how it is used by anthropologists as practitioners in different fields of design. We will attempt to see how anthropometry is used as a set of techniques associated with methods of measuring and aids in the creation of design which suits individual needs. Let us now proceed with the unit with the description of the term anthropometry and design anthropometry. इसको फिर से देख लेते हैं. Introduction part. The purpose to have a unit on design anthropometry is to take you learners through a detailed explanation of what it is, how it originated, and how it is used by anthropologists as practitioners in different fields of design. We will attempt to see how anthropometry is used as a set of techniques associated with methods of measuring and aids in the creation of design which suits individual needs. Let us now proceed with the unit with the description of the term anthropometry and design anthropometry. Anthropometry and design anthropometry. Before we give a description of what design anthropometry is, let us first understand the meaning of the term anthropometry. The term anthropometry was introduced by Georges Cuvier 1769 to 1832. He was a French naturalist. The first use of anthropometry in anthropology was, of course, in physical anthropology, where it was used to study human variability among different human races. It was also used to make a comparative study of human beings and primates. Heron, 2006. Anthropometry comes from the Greek word anthropos, that is man, and metron, that is measures. Put together, the words mean measurement of man, or in today's term, measurement of human being. The measurement done through anthropometry concentrates on bodily characteristics like body composition and body shape, which is known as static anthropometry, and measurements of bodies, movement and strength capacities, and how space is used. This is known as dynamic anthropometry. The use of anthropometry started many years ago with the same needs in mind as today, that is, in its initial stage too. Anthropometry was concerned with the collection of data of body parts to design clothes, tools, and apparatus, etc., among other things. Other applications also use measurements for assessment of height, shape, and size of other bodily areas, etc. During the early times, like the 15th century BC, body parts were also of immense interest to artists and sculptors. Works of eminent talents of the time, like Leonardo da Vinci, Albert Dürer, Alberti Piero della Francescane, etc., who were among the main protagonists of the Renaissance period, heralded the methodical commencement of anthropometry. Coming back to physical anthropology, the subject is entirely seen as an applied practical area which can be utilized for workable objectives. In the study of humans, anthropology gets associated with ergonomics, where the system of man and technique can be combined to reach new goals. In this process, ergonomic anthropology has grown along with areas of technology, engineering, physiology, and psychology, and aspires to achieve the perfect setting for this human technique system to operate. Anthropologists associated with ergonomics takes help from basic anthropology, which works towards the requirement of technology and engineering. Novak 2006. Ergonomics, or human factors, is the scientific discipline concerned with the understanding of interactions among human and other elements of a system, and the profession that applies theory, principles, data, and methods to design in order to optimize human well being and overall system performance. By now, we are clear that anthropometry is an important part in the study and applicability of ergonomics. We now proceed to understand what design anthropometry is. Design anthropometry is basically anthropometry utilized to design equipments, gears, etc., with the knowledge of bodily proportions, and is conducted with the help of measurements of human to provide them the best arrangements. Its usability extends to many fields including industrial design, kitchen design, workplace design, architecture, etc., to name a few. To take this concern forward, we will now proceed with a discussion on the various kinds of measurements involved and what the uses of design anthropometry are. Methods and measurements. Anthropometric measurements are conducted to know about the bodily dimensions for various purposes. There are some fundamental kinds of anthropometric measurements. They are linear measurements, circumferential measurements, and force measurements. In linear measurements, the breadth, height, and length of body is taken into consideration. There are specific landmarks between which these measurements are taken. To elaborate body movements recognized in the sagittal plane are known as flexion and extensions. Back and head movements in the sagittal plane are said to be bending to the right and to the left, and movements in the boundaries are known as adduction and abduction. In view of these boundaries, movements found in the transverse plane are called pronations and supination, and movements in the back are called left turns and right turns. More significant to our concern in design anthropometry is the circumferential measurements of the body, as they are mainly carried out with the intention of clothing design and physical evaluation. Here the main measurements involve head, chest, neck, arms, hips, thigh and skin circumferences. Force measurements are conducted to find out the physical inclinations of humans. In general, force is defined in relation to the exerted by that exerted by the hand and foot. Movements of forces are used as data applied to the design of hand and foot control systems, Novak 2006. To come back to the essentials, anthropometry is all about delivering impartial and exact information about the somatic makeup of humans. Due to ontogenetic developments in the body and its parts, there are periods of growth which is documented by anthropometry to define transformations in the human body. It is interesting to note that during the lifetime of a human being, the head measurements become double, the trunk measurements becomes triple, and limb measurements increases between 4 and 5 fold. The goal of anthropometry thus is not only to find out the differences in human body in terms of age, but also in terms of sex and the kind of somatic makeup observed. In case of men and women, substantial distinctions are seen in terms of their somatic structures. For example, generically women are found to be 8 to 15% smaller than men. On the basis of the secular trends, evolving styles in population are predicted and outlined with the help of anthropometry. This involves matters like development, acceleration, and secular trend. Such occurrences exhibit major variations between generations in many features like somatic, morphological, and functional. It is here that anthropometry defines these distinctions that are observed in known populations, and it is through this that ergonomics makes use of data and builds products and materials attuned to the body shape and structure. This innovation in ergonomics has culminated in the creation and use of methods and measures utilized to anthropometry, and from this development targeted at the needs of ergonomics has given rise to the relatively new ergonomics anthropometry. Hence, we cannot discuss design anthropometry without an understanding of ergonomics or its relationship with anthropometry. In fact, ergonomics anthropometry and design anthropometry complement each other and at times can be seen as one and the same thing. Ergonomics anthropometry thrives to make available information about the physical character of human beings so as to assist the designing of work and living conditions. This agenda has contributed to alterations in the current techniques and the creation of new methods. To cite some example for height measurements, the chief point of reference is the horizontal area of the foot rest called basis B. The modification added to such measurements is an additional vertical plane basis called basis dorsalis B small d. This has been added to facilitate the requirements of ergonomics. This basis is used to determine the body dimensions in the sagittal plane. A body which is measured in a sitting position, we now find in it the addition of two reference points. One is the horizontal seat plane, that is basis sadalis B small s, and the other is the basis sadalis dorsalis basis sedilis dorsalis, b small s small d, bsd. Such additions have been developed in ergonomics anthropometry in order to resolve concerns associated with the needs of the designers and creators of mechanical appliances and equipments. Damon et al. 1966, Bullock 1974, Novak 1978. In the early stage, ergonomics anthropometry dealt with adult humans as their main subject, as initially ergonomics was only interested in the work environment of humans. However, with time, as interest in ergonomics expanded to incorporate newer areas like home ergonomics and leisure ergonomics, it became necessary to seek help and benefit from the information present day anthropometry could provide about the different stages of human growth. Children, young people, and adults, including the elderly, are differentiated in anthropometry by using ontogenetic periods as the criterion for categorization. Anthropometry is well endowed with ample measuring methods to study these groups. The various kinds of measurements used are length measurements for infant conducted in the prone position with the help of a special kind of a librometer. In adults, the same measurements is conducted in the sitting position with the use of vertical anthropometer. There are methods of measuring which are conducted at a distance. They are most suitable to both the investigator and the subject and are called as non-tactile methods. This type of method is usually applied on disabled people and was first practiced by the Swedish researcher named Thoren 1994 with the use of a set of mirrors and cameras and connected to CAD or CAM software. Such